Hello friends, in this video I am going to solve you 4 important problems on systems and signals subject for the GATE 2023. Here is the first question, that is, which of the following can be impulse response of causal system? Here I am going to explain you concept with the problem. First, understand what is causal system. Here the causal system is nothing but the system output whose output is depends on the present and past values of the input. Okay, present and past values of the input, that system is called causal system. Here they are given the four impulse responses, that is the first one is this one, second one this one, third one and fourth one. Here we need to find which one is the correct causal system impulse response. And here I am going to tell you one more point regarding causal system. Causal system is only exist in the positive time axis. Remember this point. Causal system only exists in positive time axis. Okay. Here observe which signal is only present in positive time axis. Option A, it is present in both positive and negative time axis. So it's not a causal system. And option B, here observe option B present only in positive time axis. So we can say it is a causal system. And option C, it is also not present in only positive time axis. So it's not causal. And here also it is present in negative time axis, so it is not causal system. Here option B is a correct answer, it is a causal system. Suppose if the question asked like this, that is, find the impulse response of non-causal system. For causal system we can simply say if the impulse response is only present in positive x-axis, then that is a causal system. If the impulse response is present in both positive and negative time axis, then that system is called non-causal system. Here option A and option C are the examples of non-causal systems. Okay, because here the impulse response is present in both the positive and negative time axis, here also in option C. And when the same question is asked like this, find the impulse response of anti-causal system. Okay, anti-causal system. Here anti-causal means the system impulse response only present in the negative time axis. Here observe option D is the correct answer for the question for anti-causal. Okay, observe here we covered 3 questions, that is causal, non-causal and anti-causal. Causal is present in only positive time axis, non-causal is present in both positive and negative time axis, and anti-causal is present in only negative time axis. Okay, this type of questions we can solve within seconds and we can save time in GATE 2023. And moving to next question, that is, the function x of t is shown in the figure. Here already they shown the function x of t. It is a signum function. Okay, and we need to find even and odd parts of unit step function are given below. That means here we need to find the even and odd parts of the unit step function as a function of signum function. Okay, here our reference signal is signum function. We need to find the even and odd parts for the unit step function. For that, first we need to draw one unit step function. Okay, this is the unit step function u of t. We know unit step function is only exist in positive time axis having amplitude 1 from 0 to infinity. This is the unit step function. You know, for finding the even and odd parts of the every signal is having both even and odd parts. Remember this signal. Remember this. Every signal like u of t is a unit step signal which is having both even part plus odd part. Here ue of t is nothing but even part present in u of t, and u of t is nothing but even part present in u of t. Here first we need to find the even and odd parts of this unit step function, and we need to write that even and odd parts in terms of this signum function x of t. Okay, first For finding the even part, we have one formula, that is UE of t. For even part, u of t plus u of minus t by 2. It is the formula. Okay. Here observe, we have u of t and we don't have u of minus t. U of minus t is nothing but just time reversal of u of t. That means here u of t is there. Just we need to fold this u of t into negative side. That is just a mirror image. Here observe, I will draw here. U of minus t, this is 0 and this is negative axis. Okay, here when we add the u of t plus u of minus t, okay, u of t is present in positive side with amplitude 1, u of minus t is present in negative side with amplitude 1. There is no common portion between the u of t and u of minus t, so the addition of u of t plus u of minus t is 1. Okay, the addition is 1 divided by 2. So the even part of uv of t is nothing but 1 by 2. Remember, even part is 1 by 2. Now check into options. Where is 1 by 2 present? 1 by 2 present in both A and C. Okay, 1 by 2 is present in both option A and C. Now we need to find the odd part. For odd part also there is one formula, that is u of t is equal to, here I will write in bottom, u of t is equal to u of t minus u of minus t by 2. Okay, this is the formula for finding the odd value of the unit step function. Here observe, u of t minus u of minus t is nothing but signum function. If you write this x of t, that is signum function, in terms of unit step function, then you will get the same thing, that is u of t. U of t is nothing but the positive time axis unit step function. U of minus t is nothing but this one. Okay, so we can represent this signum function as unit step function like this, that is u of t minus u of minus t by 2. We can simply replace this u of t minus u of minus t as x of t. Okay, that is u of t is equal to x of t by 2. That is nothing but 1 by 2 x of t. That is odd part of the unit step function is 1 by 2 x of t. Here observe, in option A we have 1 by 2 x of t as odd part, but in option C there is minus 1 by 2 x of t. So the correct answer is option A. Okay, this is how to find the even and odd parts of the signal. If you have any doubts, let me know in comment box. I will definitely help you to solve the problems. Okay, and the next question is, the Dirac delta function is defined as, first we need to know what is Dirac delta function. It's the another name for impulse function. We know the impulse function looks like this time axis 0. This one is the impulse function. Okay, del of t. That is, impulse function is present only at a time t equal to 0, having amplitude as infinity. Remember these 2 points. Impulse function is present in only time t equal to 0, having amplitude as infinity. By using these two, here we need to find the which one is the exact mathematical representation of Dirac delta function. Here observe, in first A, del of t is equal to 1 when t equal to 0, 0 otherwise. It's wrong, because at t equal to 0 we have amplitude as infinity, so it is wrong. And the next one is del of t is equal to infinity when t equal to 0, 0 otherwise. It is right, but we need to check 2 other options also. It is somewhat right, because at t equal to 0 we have infinity. And third option is del of t is equal to 1 when t equal to 0. It is wrong because at t equal to 0 we have infinity. And at fourth option, del of t is equal to infinity when t equal to 0 and 0 otherwise. And one more condition is there, that is integral minus infinity to infinity del of t is equal to 1. Remember this one, when we perform the integration for the impulse signal, it will give the result as 1. So here for D option, both the conditions are satisfied. Okay, so the correct answer is D. Okay, here B also mathematical representation for impulse response only, but for D, in D option, the second condition also satisfied. So the correct answer is D. Coming to the next question, that is a discrete time signal x of n is equal to sine pi square n, where n being an integer. Now the options are periodic with period pi, periodic with period pi square, periodic with period pi by 2, not periodic. First, we need to find the period, whether the signal is periodic signal or aperiodic signal, and if it is periodic signal, we need to find the period of that periodic signal, and then we need to choose the correct option. First, write this signal x of n is equal to sine pi square n. Now first we need to compare this equation with the standard equation, standard discrete time signal, that is x of n is equal to a sine 2 pi fn. This is the standard form of discrete time signal. Now compare this signal with this signal. Here in place of 2 pi f, here we have pi square. Just simply 2 pi f is equal to pi square. Here cancel out pi and pi. Then we have 2f is equal to pi. That is f is equal to 5 by 2. That is frequency is 5 by 2. We know time period is just inverse of frequency. That is time period t is equal to 2 by pi. Here observe, every time the time period is in terms of only integers, but here we have pi also. So the signal is not a periodic signal. Okay, we can say a signal is a periodic or non-periodic signal by simply observing the time period. The time period is only in terms of integers only, but here the time period is not only in integers, it is the fraction part. I mean, it is included with the pi. Okay, so it is not a periodic signal. So the option D is correct. That is, it is not a periodic signal. And this is about this video. If you have any doubts, let me know in the comment box. I will give you my mail ID and my Telegram group in description. If you have any questions regarding GATE ECE 2023, please mail me or message me in my Telegram group. I will give you these links in description box. I will definitely answer you. And thank you for watching this video.